All right, it's time to turn to page 11. And as we're looking at page 11, we are going to need to remember what we were just talking about as far as what we were saying about like the sandwiches, okay? Where if you want to compare one substance to another substance, we have to use the ratios in our reaction. Those coefficients are going to be very important to us. So, let's look at this in terms of chemistry. In moles, we compare those ratios using the coefficients, where the coefficients are numbers of moles. Those are numbers of moles every time. So we call these not just ratios like 1 C2H4 to 3 oxygen or 2 carbon dioxide to 2 water. Those aren't just ratios, those are mole ratios. So it's 2 moles of carbon dioxide to 2 moles of water. We're going to go back to color coding. Remember that we always use green for moles. And let's take a look at how we would show the work for a stoichiometry problem, a real one that uses actual chemistry. So if I have 8 moles of oxygen gas, that's the O2, by the way, that's oxygen gas, how many moles of water will I produce? So we're going to draw ourselves a little bridge to help us remember what we're doing. The bridge starts at oxygen, so I'm going to put a big dot here, like this is where I'm starting, and it points at water, because they are asking me to start with oxygen, and they are asking me how many moles of water. So they gave me an amount of oxygen, they're asking me about water, so I'm going to start at oxygen, and I'm going to point to water. So here's my little bridge, taking me from one thing to the next thing. Once I have that little bridge drawn, we can draw some fractions. We always put whatever they gave us, the given, over 1. That is staying the same as in our previous unit. The given over 1 is still always our first fraction. So we use 8 moles of O2. And what else is staying the same is that what goes up must come down. So your units, moles of O2, are going to come down to be here, moles of O2. Okay, from moles of O2, we drew a little bridge that from moles of O2, we go to moles of water. So your bridge is taking you from the bottom of the fraction to the top of the fraction. So moles of O2 were at the beginning of the bridge and at the bottom of your fraction. The end of the bridge points to moles of water. That's what I'm going to put on the top of the fraction, moles of water. And what we used to say is that in front of the word mole we would always put a 1. But now we have a new kind of fraction we never did before. We never did a fraction before that was converting moles and moles. We've never had a green and green, mole and mole fraction. So when you have 2 moles in the same fraction, you're not going to use 1 mole anymore. You're going to use your numbers from the bridge, which is why part of why we drew the bridge, to help ourselves remind ourselves what numbers we're using. So not only am I starting with moles of oxygen, I'm starting with 3 moles of oxygen. So this 3 is going to come down here. And I'm ending not only with moles of water, but with 2 moles of water. So the bridge is pointing at 2 moles of water. That takes me to the top of my fraction. I need not only moles of water, I need 2 moles of water. So this 2 is going to come to the top of my fraction. That 2 is coming here. From there, we just do the math. Remember to multiply the top, divide by the bottom. So 8 times 2 is 16. 1 times 3 is 3. And 16 over 3 is 5.33. And whatever's on top of your last fraction, that's what units your answer should have. So moles of water is what we're ending with. You'll notice that in our old unit, we used to say you could only use each thing twice, and then you had to switch units. Here we've used moles 4 times, so it seems like we've used something 4 times, but if you notice that I labeled the chemicals, we still only used each thing twice. I used moles of O2 twice, and then I switched to moles of water, which I used twice. Moles of O2 got used twice, and then I switched to moles of water, and that got used twice. So if we were going to do a little step-by-step, we can write this in some of this empty space up here. Okay. You're still going to do, for your beginning setup, the given over 1 is still step 1. Step 2 is still what goes up must come down. But now, instead of using each thing twice and then switching, we're going to use specifically moles 4 times to with each chemical. Okay, so I used moles 4 times in this problem, twice with oxygen and twice with water. Twice with oxygen, twice with water. Okay, so let's try the next problem. If I produce 0.5 moles of CO2, how many moles of C2H4 reacted? So I see that they're asking me, they're giving me 0.5 moles of CO2. That's where I'm going to start. They're asking me to find C2H4. That's where I'm going to end. So I'm going to end the reaction, draw a bridge from CO2 to C2H4. So I'm going to come back up here in the reaction. This one was for part 1, problem number 1. For problem number 2, I start at CO2 and I end at C2H4. So this is my bridge for problem 2. Starting at CO2 and ending at C2H4. The bridge is important because it's going to help us remember what number of moles to use. So again, we're going to draw 2 fractions here. We're going to put what they gave us over 1. Given over 1 is still our first fraction. 0.5 moles of CO2 over 1. My next step, what goes up must come down. So if I have moles of CO2 on top, then I'm going to need moles of CO2 on bottom. Okay, that's used moles twice with the first chemical. I have to use it twice with each chemical for a total of 4 times. So that means I've used it twice with the first chemical. Now I have to use it 2 more times with the other chemical. So I switch from CO2 to the other chemical, C2H4. Now we not only switch units. Last time with unit 8, we would switch units from moles to grams or moles to molecules or whatever. Now we have to switch chemicals. So it's really important that you label your chemicals so you can show yourself, this is where I'm switching chemicals. When we have our mole over mole fraction, this is when we're using the bridge. We started at moles of CO2 and turned it into moles of C2H4. So that's what our bridge is doing, from moles of CO2 to moles of C2H4. Our numbers are going to come from the coefficients up here. So I've got 2 moles of CO2 as my coefficient at the beginning of my bridge. So 2 moles of CO2 is going to be my coefficient in the reaction, or excuse me, in the fraction. And then at the end of my bridge, I have 1 mole of C2H4. So this 1 mole right here is going to be how many moles of C2H4 I have down here. From there, we do our math. Multiply the top. 0.5 times 1 is 0.5. Multiply the bottom. 1 times 2 is 2. And then we divide. 0.5 over 2 is 0.25. I still need to use moles a fourth time, the second time with my second chemical. So this is going to get labeled moles of C2H4. It's a 4, sorry, for my final answer. So we could even add a fourth step up here to remind ourselves that in the mole over mole fraction, the number of moles for each chemical is the coefficient from the reaction. Let's look at page 12. I've been talking about a bridge, I've been drawing it, and you're going, that's not a bridge, that's just an arrow, crazy lady. Well, I call it a bridge because it's one of my stupid memory tricks. You know all my memory tricks are dumb, right? We've been talking about this all year. All my memory tricks are dumb. This is also dumb, but it works. We call this a bridge. It's not an arrow, it's a bridge. We call this bridge the mole bridge. The mole bridge is a toll bridge. You know what a toll bridge is? You have to pay money to get on the bridge, and then you have to pay again to get off. That's how toll bridges work. You have to pay to get on and pay to get off. The only currency accepted by the mole bridge toll workers is moles. If you want to get on the bridge, you have to pay them in moles. If you want to get off the bridge, you have to pay them in moles. You cannot pay in anything other than moles. You can't get on the bridge if you're trying to give them anything other than moles. You can't get off the bridge if you try to give them anything other than moles. They will not let you on or off the bridge if you try to pay in something else. If you try to pay in grams, no bridge for you. No, they're going to make you go back to Canada. Okay, no grams. I say back to Canada, get it? Because like in Canada they don't use pounds, they use a metric system, they use grams. So if you try to pay in grams, no bridge for you, they're going to make you go back to Canada. Okay, you have to use moles. This part is going to come in more useful when we get to page 13, but it is going to come back to us. We are going to come back to that. Okay. Anyway, we're going to do a little example with this new reaction. Number 1 says how many moles of iron metal are needed to react completely with 2.45 moles of oxygen gas. So they're giving us 2.45 moles of oxygen gas. That means my bridge is going to start at oxygen, O2. And they want to know about how many moles of iron metal. So that's where my bridge is going to point, to iron, Fe. So I'm going to draw my bridge in the reaction. It starts at 3 moles of O2. It points at 4 moles of Fe. So I'm going to draw 2 fractions. They gave me 2.45 moles of oxygen, so I'm going to write 2.45 moles of O2 over 1. That's the given over 1. That's my first step. My second step, just like before, just like in our last unit, my second step is what goes up must come down. So moles of O2 will come to the bottom. But now we can't automatically put a 1 in front of this O2 anymore. In front of this mole anymore, I mean. We can't automatically put a 1 anymore. Because now when we need a number of moles, we're going to be taking it from our coefficients. In fact, my number of moles of O2, remember this fraction is where the bridge is. The bridge starts on the bottom with 3 moles of O2. So I write 3 moles of O2 here. And I cross the bridge, drive. It's pointing at 4. For what? Remember, the bridge is always moles. Okay, the bridge is always moles. So it's not just pointing at 4, it's pointing at 4 moles of iron. So that's what goes on top. You're going to multiply this out, and you can put the whole thing in your calculator at once, really. 2.45 times 4 divided by 3 gets you 3.2, we're rounding to the hundredths place, so 3.27 moles of iron. Remember, we use moles 4 times now, twice with each chemical. So here I've used it 1, 2, 3, 4 times. 1, 2, 2 times with oxygen, 1, 2, 2 times with iron. Okay, let's look at number 2. Number 2, how many moles of iron 3 oxide will be synthesized if you start with 9.2 moles of iron metal? So they're starting me with 9.2 moles of iron metal, so that's where my bridge is going to start, up here with iron. They're asking about iron 3 oxide. If you're not positive which one of those things that is, well, this is obviously just iron. This is just oxygen. This is the only thing in here that's iron and oxygen, so that must be what they're asking me to point at, even if you don't remember how to write a formula from the names. Process of elimination, my friends. So we're going from iron to iron 3 oxide. We're going to draw our fractions. Take the given 9.2 moles of iron over 1. What goes up must come down. Moles of iron on top. I'm going to put moles of iron on the bottom. Now we're supposed to be using moles 4 times, right? Twice with each chemical. So I've used it twice with iron. I have to use it a 3rd time on top of this fraction. The 4th time is going to be in my answer. But the 3rd and 4th time need to be a different chemical than the one I started with. I already started with iron. Here's iron. The other chemical in this problem is iron 3 oxide, which we decided was this thing. So the Fe2O3 is what's going to go here and in my answer. So that now I've used moles 1, 2, 3, 4 times, and it was twice with each chemical. Twice with iron, twice with Fe2O3. Remember, these numbers in this fraction, those come from my bridge. So the bottom of my fraction is the start of my bridge. My bridge started with Fe, and there were 4 moles here. So this 4 is going to come in here. My bridge points at Fe2O3, and there are 2 moles here. So this 2 is going to come down here. Then we just stick it in our calculator, 9.2 times 2 divided by 4. And we get 4.6 moles of Fe2O3. Okay. Yes, you have to show your work the way I'm showing my work, because it's going to get harder. And when it gets harder, if you don't show your work like this, you're not going to be able to do it. Okay? Yes, you have to show your work like this. I'm going to end this video because it's time for you to practice for yourself. Gee, what should go in these blanks?